Okay, so we've multiplied, we've divided, we've raised to a power, we've even added and subtracted, which meant we had to go back to rectangular form to do that. So let's now take roots of complex numbers using DeMoivre's theorem. Look it up if you'd like. This is what we're going to think in terms of taking roots. We all know that the square root of 4 is 2, because 2 times 2 is 4. But we've learned prior that to find the square root of a number, because the index is a 2, you can take 4 and raise it to the 1/2 power. And that would also give you the answer of 2. It's how we used to do this in the olden days when we didn't know how to take the square root of 4. Now, that one was okay, but square root of 5, for example. We didn't know what that value was, and we didn't have calculators to do this. Even me, if you can believe that, and I'm not that old. So, you know, square root of 5 in the olden days was thought of taking 5 to the 1/2 power, and then we use logarithms to solve that, because it's so much easier using logarithms. So what we're going to do today, when we want to take roots, square roots of a complex number, instead we're going to raise it to the 1/2 power. If we want to take a cube root of a complex number, I know that answer is 2, because 2 times 2 times 2 is 8. But instead, we're going to raise 8 to the 1/3 power. You've got to put the 1/3 in parentheses, or it will just raise it to the first power. So if you don't go 8 caret 1/3 in parentheses to get the 2, it will make a mistake. You know, here's another fairly simple one, but you know, even our graphing calculator, to get this, you have to hit the math key, and then I think it's under the math key. I'm going to grab my calculator. For me, it's item number 5 on that menu. But before I even go there, I have to tell it, I have to hit the 5, then I have to hit the math key, and then I hit that key that's got a little X here and then a root. And then I put the 32 in. Or I could just take 32 and raise it to the 1/5 power. And it's going to tell me that the answer is 2. So what we're going to do here in this topic is we're going to find, for example, the cube roots of this complex number. So we're just going to raise it to the 1/3 power. Now remember, when we took an angle, I'm making this problem up. This is just a different problem. When we took 5 at an angle of 42 degrees and squared it, we took the r value and squared it, and we took the angle of 42 degrees and we multiplied it by the exponent and got 84 degrees, and 5 squared is 25. So to do this, we've got to take the r value and raise it to the 1/3 power, and we've got to take the angle of 120 degrees and multiply it by the exponent, which means multiply it by 1/3. Multiplying by 1/3, remember, is the same thing as dividing by 3. So I'm just going to divide by 3. 27 to the 1/3 power is the cubed root of 27. That's what it is. And the cubed root of 27 is number 3. 120 divided by 3 is 40 degrees. And this is called our first cube root. But there are 3 cube roots of this number. There are 3 answers for this. And the way you go about finding the next answer is to take this 120 degrees and add 360 degrees to it. And now you're working with a 480 degree angle. You don't do anything else. You have 27 at an angle of 480 degrees. That number is the same as the given number. And when you raise that to the 1/3 power, the 27 gets raised to the 1/3, and the 480 gets divided by 3. So you still have, for your next answer, 27 to the 1/3 is still an r value of 3. But 480 divided by 3 is 160 degrees. And this one is called the second root of the 3 cube roots. To find the next one, we take the 480 degrees and we add 360 to that. Again, because that's another coterminal angle. That sum is 840 degrees. So now, to find the third answer to this problem, I take 27 and I raise it to the 1/3 power, which is still 3. And I take the 840 and I divide by 3. And 840 divided by 3 is 280 degrees. And I have what's called my third root. if I were to do this process again, if I were to add 360 to 840 degrees, 840 plus 360 is 1200 degrees. And if I took 1200 degrees and divided it by 3, I'd get an angle of 400 degrees. And if I subtracted 360 from that to reduce it, I'd get a 40-degree angle. Look at my first answer. It was a 40-degree angle. So if I did this again, I'd come back to my first answer, and so I'd be reduplicating all of my effort. So there are 3 answers to this problem when I asked you to find the 3 cube roots of 27 at an angle of 120 degrees. And they all turned out to be 3 because the cube root of 27 is 3. And their angles were 40 degrees, then 160, and then 280. Would you please notice how far apart these answers are, the 40 and the 160? Aren't they 120 degrees apart? And how about the 160 to the 280? Isn't it 120 degrees apart? And so I'm just going to do a little illustration here. My first answer was 3 at 40 degrees, so about right there. That's supposed to have been a 40-degree angle, but the computer decided to make a decision for me. The next one was at 120 degrees. And the next one was at 280 degrees. And again, this looks more like 270. But would you just notice that each of these was separated by 120 degrees. And so from now on, what I'm going to do, when I want 3 answers, I'm going to take 360 degrees and divide it by 3 and find out that the separation of these answers should be 120 degrees apart. So once I get the first one, the 40 degrees, I'm just going to add 120 to it. And then I'm going to add 120 to it. And I'll have the 3 answers. This one is such an odd one that I'm going to skip this for now, and I'm going to make up a new problem. And what I want to do is I want to find the 5/5 roots of 32 at an angle of 20 degrees. I want to do that because square roots, there's only 2 answers, and they're 180 degrees apart. And so it's not an odd one. It's just that I want to have you deal with getting 5 different answers. So if I want to raise this to the 1/5 power, the first one is 32 to the 1/5 power. And I just have to take the angle and multiply it by 1/5 or divide by 5. 32 to the 1/5 power, means this. And 2 is the number that you'd multiply times itself 5 times to get 32. 20 degrees divided by 5, so your first root would be at 4 degrees. The R value would be 2, and its angle would be 4 degrees. Now there's going to be a second root, a third, a fourth, and a 5th root that are all answers to this problem. But if you would think with me about a circle and think about taking, the first root is just above 0 degrees. It's at 4 degrees. But if you were to take the 360 degrees and want to separate all these answers equally, and there were going to be 5 of them, you'd take 360 divided by 5, and you'd find out that all these answers would be separated by 72 degrees. So if your first answer was at 4 degrees, then when you add 72 to that, your second answer is going to be at 76 degrees. And it's going to be located about right here. Remember, it's a vector. 72 degrees between the 2 answers. The next answer would be, if you add 72 to that, it looks to me like that's 148 degrees. So that's into the second quadrant, getting close to being 180 degrees. If you add 72 to that, 8 and 2 is 10, carry the 1, that's I think that's 220 degrees is where your fourth answer is. Well, here's 180, so 220 is about right there. And then when you add 72 again, your fifth answer is going to be at 292 degrees. 2 at 292 degrees. Here's 270, so that's about right there. So please know that pictorially, when you look at DeMoivre's theorem and you read about it in the book, it's going to show you that the 5 answers are separated by 72 degrees, and you don't have to go through the business of adding 360 to this and dividing by 5 and adding 360 to the next one and dividing by 5. You can just equally separate these by the 72 degrees. Okay, let's see. I think I'll skip the square root problem and have you practice this a bit. This is the conclusion of our complex number summary. Interesting, maybe something you haven't heard in your lifetime.